All right, hi everybody. Welcome back. Sorry, was outside for a lot of the day today. I'm a little sunburnt. Um, anyway, so welcome back. I am three people. We have a very interesting yet difficult topic in a way for you guys today. Today you're going to be looking at solving rational equations. Now, if you don't remember, rational equations, the only difference between an equation and an expression is that equations have equal signs, and you're going to have to tell me, hey, what value of x solves this equation? All right, so that's your guys' plan for today. But because these things look and act like fractions, there's some complications along the way, and we have to make sure that we address those. So what I've done today is I kind of just told you, you know what, here's the hard part. You guys have tackled equations like this before, and you might not remember, but what you did probably is you cross-multiplied and you changed it so that it said something like this, okay? Now, that's what we would normally do for an equation like this. You'd start moving some of your numbers around. We get x by itself, and we're going to find out, oh, okay, in this case, x is equal to 2. Now, that's kind of what we're going to be doing here, but think about it. The reason we changed this is because this form is something that we can't really play around with and we can't really solve very easily. So we had to change the equation into something that we can deal with and can work with. And that's what we're going to have to do today. We cannot solve an equation that's a fraction if everything else in the equation looks like a fraction. We have to deal with what we know. So that's kind of hard part number one, is we're going to have to change this equation so we can work with it. Now the other hard part is this right here. We are not supposed to have a denominator down here of 0. So if we pretend for a minute that maybe we had 2x like this, okay? If we had 2x and we were subtracting 2x, we'd find out essentially that we get a number that we can't use. And if you try to make a denominator 0, you broke math. Denominators of 0 essentially are what we call undefined. We can't play with that. That's not an answer that helps us. So one thing we're going to have to watch out for today as well, which seems to be kind of the problem that everybody has with these, is we can't get answers we can't use. And we can't use numbers that give us denominators that are 0. If we have a denominator of 0, we broke math, so we can't use it. So what I've outlined essentially at this point is steps that we're going to tackle. It looks relatively simple. And the problem with rational expressions, not the problem, I keep saying the problem like there's one. The problem with rational expressions is everyone kind of has to be tackled on an individual basis. It's not like two-step equations. You do this, you do that, you're done. You actually need to look at what's happening in each one and kind of play with it from there. So here's our steps. Our steps are to factor all common denominators, or all denominators, I should say, that's bad. Factor all denominators and find excluded values. You guys have heard me talking about that for a little while. Excluded values are numbers that give us 0 in the denominator, and that was the reason why I told you we needed to worry about those, okay? Now beyond that, just to remind you, those are values of x that make our denominator 0. We're just going to kind of write those down, set them off to the side so that if we do get an answer that is an excluded value, we know not to use it, okay? Step 2, we're going to decide on a common denominator for the entire equation. So you're going to look at all denominators and say, what would be common for all of these fractions? And then we're going to multiply all terms in the whole equation by those common denominators, okay? Now the whole point of that is to get to step 3. Step 3 is to cancel out all denominators and then multiply out the numerators, all right? So our goal kind of today is to get rid of everything that looks like a fraction, like we did here, so we can actually work with it. And this is actually an old trick that works for more than just this. All right, after that, step 4, solve for what's left. That's gonna be a regular equation. It might be a quadratic solving of some kind, which you guys, most of the time on these, you guys are going to be able to do with quadratic factoring or x factoring, as you guys have heard me call it before. You might even have to use the quadratic equation, all right? So just after you get everything into a regular equation form with no fractions, you have to essentially figure out, all right, how am I going to actually tackle this thing and solve it, okay? So those are our steps. That's kind of what we're going to be looking at today. We have 3 examples that we're going to try. There will be a quiz is up for this particular topic. It'll be due on Tuesday night, and I will be holding my office hours on Tuesday at 11 a.m. I'm sure that I'm going to have probably the same people. I wish there were more, just because there's no way everyone's getting all this usually. But we're going to have office hours for that, so I'm ready to answer any of your guys' questions. Any question that comes up that's tough, make sure you write it down and I'll help you out. Here's our first example, and I've kind of realized that it's a little bit easier for me to just do one equation each time we do an example, so that I'm not worrying about board space too much. So that's why we just have the one for now. Better have my list of my other 2 examples so we don't lose those. Okay. All right. So here's our first one. We're going to look at all the denominators. In this case, there's only 2. Yes, there's an equal sign. Don't worry about it. We will get to that later. We're going to make sure that we factor these as much as possible. X minus 5, I cannot factor any further. There's no common number to take out. There's no quadratic terms for me to factor. So I can't do anything with that. We're going to look here, though. The 2x minus 10. There is a common number that both 2 and 10 can be divided by, and we should factor that out. If you factor out a 2, you will find out that 2 divided by 2 will leave you with just an x, and 10 divided by 2 will leave you with just a negative 5. So this is our second denominator fully factored, okay? While we're doing that, or once we're done factoring all of our denominators, this is an easy one so you guys kind of get the gist here. Once we've factored our denominators, we're going to write down, okay, what are some values that we are going to have to exclude? What's going to make this x minus 5 equal to 0? What's going to make this denominator equal to 0? It might be one thing, it might be more than one thing, depends on the numbers. So what's going to make an x take away 5 a 0? A positive 5 will. So that's one of the numbers we cannot use. 2. 2 does not have an x attached to it. There's one here, but it's separate in its own factor. 2 does not give us an excluded value. However, the x minus 5 right here will give us an excluded value of 5. So what you're going to see, the excluded value, and in fact the only excluded value that we have for this equation, is 5. If we get a positive 5 as our answer, we cannot use this. Now, normally people ask this question of, well, if I can't get answers, do I ever have regular equations that don't have a solution? Yes, that happens all the time. So be on the lookout for that, okay? Now, next thing, figure out what your common denominator would be for both of these denominators. Well, this says that we need an x minus 5. So we're going to write it. And this denominator says not only do you need an x minus 5, but you need a 2. Okay, so this is step 2, I think. Yeah, so step 2 is here. This would be our common denominator, and we're going to multiply by that common denominator, which is 2 and x minus 5 together everywhere, okay? Now the whole point of that, essentially, is so that this happens, okay? And some of you saw this when we were in our Zoom session the other day, some of you did not, which is why I highly recommend you come to them. If you can't, I understand. We're going to cancel out these denominators with these multiplications that we're going to times by and see what cancels out. Whatever's left, we're going to times our numerators by that. That's what step 3 essentially is about. So check this out. Here's an x minus 5, and here's an x minus 5. These x minus 5s cancel out. Okay? Here's a 2, there's a 2. One in top, one in bottom. Those 2s will cancel out. Here's an x minus 5, and there's an x minus 5. Those will cancel out. All right, so that was essentially step 2. Now step 3, we're going to actually multiply all of our numerators by what's left. We wanted all of our denominators to cancel out here, and they did. That's what we wanted. We've changed our equation so it's something we can work with, but preserved what our numbers are supposed to say. So all I have to do is times 3x plus 7 by a 2, which would give me 2 times 3 is 6 with x attached to it. 2 times 7 is 14. That's the first numerator, followed by an equal sign. Okay. Everything canceled out here. There's no 2, there's no more x minus 5s. Those canceled out down here. So the only thing left for me to play around with is the 5x plus 17. All right. Now this is where you guys have to remember kind of how these things went. You have got essentially to figure out, all right, do I have a quadratic or do I have a regular equation that I need to solve? Quadratics, remember, have x squared in them. Do you see any x squareds here? No, you do not. So we have a regular equation to solve. Now, if you don't know how to do that, I feel really bad for you. You have to get all the x's. There's 2 x's on each side. There's 2 regular numbers on each side. All x's have to go to the same side. I have to move them with addition or subtraction. I'm going to move the 5x onto the left. And at the same time, that's going to cancel this guy out. At the same time, I'm going to move the 14 over here, my regular number with no x's on it, over to this 17 using subtraction. So if you look, no more x's on the right side, no more plain numbers on the left side. We'll see what's left. 6x minus 5x, that's just an x, nice. 17 minus 14, can't do that, I feel bad for you. That is just 3. And if you look, we're done. All we have to do is check to make sure that this number right here is not one of our excluded values that we knew we could not use in the beginning. So check it out. Is 3 a 5? We aren't allowed to use 5. So is this 5? No, it's 3. 3 is not 5. So are we allowed to use this answer? Yes, we are. Okay, and you're done. That's it. All right. Now remember, that's an easy one. Some of these are going to have you doing quadratic factor solving, all kinds of different fun things that you guys probably forgot about in the month that we've been in this whole quarantine thing. Okay? All right, example number 2. Make sure I have enough room for me on this one, as everybody gets lost on these. Now this example, I'll just tell you guys, this example is meant to get us thinking about what if we get a number we can't use. All right, so we're going to kind of play with that in a second. Now notice how I'm going to write this. This first fraction, I'm going to give myself a decent amount of space because I know I'm going to probably run out of room on these. All right, so it's a 2x minus 9 plus an x over 2 is equal to a 5 over x minus 7. Okay, and I'm keeping a lot of these relatively basic. Just so that we can kind of start. The third one has a little more oomph to it. You might have a little more work to do there. So here we go. All right, look at all your denominators. This is factored. A plain 2, that's already factored. X minus 7, that's already factored. So step 1 for us is almost done. We just have to decide, well, what are some numbers that we're not allowed to use? What are some excluded values that we can't use? Well, what's going to make an x take away 7? A 0. 7 is. So that's one of our excluded values. If we get a 7, we can't use it. 2, are there any x's here with this 2? No. So there's nothing we could plug in for x that's going to give us a 0 here. Nothing to worry about. This is another x minus 7. That just means we can't use a 7, which we already knew. So we're pretty much kind of ready to go to our next step. All right. Next step, decide on a common denominator for this whole equation. So I'm going to look here. The first thing this says that I need is an x minus 7. Okay. The second fraction says you also need a regular 2 by itself. And this last fraction, even though it's on the equal sign over here, we still talk about it, says you also need an x minus 7. We already talked about it. It doesn't say we need 2 of them. It says we need 1 of them. And we're already kind of thinking about what's going to happen if we need that one single x minus 7. So no more to worry about here. So this is what we're going to times all of our terms by. A 2 and an x minus 7. A 2 and an x minus 7. Now, once you know what you're timesing everything by, we hope that all of our denominators cancel out and whatever's left is left, and we'll just multiply everything through. So looking here, first fraction. I see there's an x minus 7 in the bottom, and I see there's 1 in the top. So those x minus 7s will cancel. But what's left? A 2. So 2 is going to times that. Next fraction, I see that there is a 2 in the bottom and a 2 in the top. So those 2's will cancel. There is not an x minus 7 down here, so I don't get to cancel that out. And I'll actually have to times both of these together. Okay? Third fraction. Here's another x minus 7. Here's an x minus 7, top and bottom. Those will cancel out. And we'll see that we have a 2 here, an x minus 7 to times by here, and a 2 here. Now, a lot of you like to see this step and this work, so I'm going to write it out like this. What we have left, notice all our denominators are gone. We have a 2 that has to times 2x minus 9. That was our first numerator. And we have an x that has to times an x minus 7. That was our second numerator. And we have a 5 timesing 2. There's a dot there. It might be hard to see. Okay? And all we have to do is multiply these out and figure out how to solve them. It's not that bad. Well, 2 times 2, that gives me 4x. 2 times minus 9, that gives me negative 18. There's a plus sign here, so I don't keep going with my multiplication. I look at what's next. Here's an x times an x. We have to distribute like usual. X times x is x squared. Here's an x times a negative 7. That should give you negative 7x. And it is all supposed to equal 5 times 2. If you can't do that, I feel bad for you, son. 10. Okay? Now, hopefully, you guys are getting used, or you have been at least, used to the idea of we're probably going to have to combine like terms, and then we're probably still going to have to solve something. Well, do I have any like terms here? The term that's most concerning is x squared. I do not see any other x squared, so I'm going to keep that there. There's a 4x here and a negative 7x there. Put both of those together. Here's the 4x. Here's the negative 7x. That should give me negative 3x. And here's a minus 18. And it was all supposed to equal 10. This is the left side of the equation cleaned up. This is the number that is left on the right side. Sometimes it will be terms, like there might be x's over here. You'll just have to move everything over when you're done. Now, is this a regular solving question or is it a quadratic solving question? Well, the thing that tells me is that this is squared. This is a quadratic solving question. You guys have not done these in a little while. You can only solve quadratics when they are equal to 0. That is correct. So, right now, this is not equal to 0. We're going to have to move this 10 over here so that it is equal to 0. The way that we do that is we subtract 10 just like that. Okay? That will leave me with x squared minus 3x minus 28 is all equal to 0. Okay? Since it's equal to 0, we're really hoping that this factors, or we can solve it by factoring. If we can't solve it by factoring, it's going to be kind of rough. We'd have to do like completing the square or quadratic formula or something crappy like that. Okay, we really don't want to do that. So we're trying to see, hopefully this factor is negative. So you guys know, I do not do these problems before I put them up here. I want to run into mistakes just like you guys do. And difficult problems just like you guys do, so that you can kind of see that, you know, I don't just rehearse this and redo it. I do it in real time, other than the steps, so that I kind of know what problems you guys might come across, okay? Now, for this to factor, we need to times to a negative 28 and add or subtract to a 3. There's a couple of ways to make 28. 2 and 14 would work, but those will never add or subtract to a 3. 28 and 1, never going to add or subtract to a 3. But what is going to work is going to be 7 and 4. 7 and 4 times to 28, and I could subtract them to have a difference of 3. But I need them to have a difference of negative 3. So which of these, the 7 or the 4, is negative? The 7 is. Negative 7 plus 4 would give me negative 3. So what this means, and this is just me kind of reminding you guys, is this will factor with an x minus 7 and an x plus 4. And it's all equal to 0. Okay? It's been a while. The reason we need this equal to 0 is because we're going to take each of these, the x minus 7, the x plus 4. We're going to apply ZPP, which is the zero product property. And then we're just going to solve them. Well, one of our answers is a 7. One of our answers, if we solve this, is going to be negative 4. So these are our two answers. We have 7 and we have negative 4. As far as we know, both of them work. But here's the thing. We wrote down in the beginning, right here, that we cannot use an answer like positive 7. Look at that. We have an answer that's positive 7. You are not allowed to use that. You told yourself you're not allowed to use that in the beginning of the problem. So the only answer that actually works for us is x equals negative 4. All right? And that's our second example, example number 2. Now, just a quick reminder, remember, you guys can go, if I was asking you to factor these, this is what you would have to do. If I asked you to solve this, there's a shortcut here. Just change the sign. This essentially says you should get a positive 7, and this says you should get a negative 4. We can't use the positive 7. That's why negative 4 is our number that works. So hopefully you guys remember that trick. Okay, well, it's not really a trick. It's what you're supposed to do. Okay. All right, moving on. Third and final example, and then I have to leave you guys to it. I hate to do that. I really miss doing this in real time with real faces in front of me. It can become real difficult if I don't have the ability to look at you guys and realize, oh, they are totally lost. I have to reteach something. So here is our third and final example. And I'm keeping these relatively easy on the examples just because my videos keep taking a decent amount of time. So here's an 8 over x plus 3 is equal to x plus 1 over x plus 6. Okay. All right. Step 1. Again, I need to factor my denominators. Nothing to factor, nothing to factor. I want to make sure that I write down what my excluded values are. Okay, answers that I can't use. Well, what's going to make an x plus 3 a 0? Negative 3 will. Can't use it if I get it. What's going to make x plus 6 a 0? Negative 6 will. Can't use it if I get it. Okay, that's step 2. Or step 1. Step 2. We need to decide on a common denominator. You guys might notice I tend to keep doing it off to the side here and then just putting everything back in for all the terms later. Well, this denominator says you have to have an x plus 6 or x plus 3, Watley. No x plus 3, no common denominator. Fine. This fraction also says, hey, you also need an x plus 6. There are no other denominators to look at. My common denominator that I would use would be this. All right? So all of these terms are going to get times by an x plus 3 and an x plus 6. And remember, our goal is to make sure that all of our denominators are gone by the time we're getting ready to solve this. And here's where that happens. Here's an x plus 3 in the bottom. We're timesing by an x plus 3 in the top. Those should cancel out. Here's an x plus 6 in the bottom. There's an x plus 6 in the top. Those should cancel out. In our first fraction, we're timesing by an x plus 6 because that's all that was left. In our second fraction, we're timesing by an x plus 3 because that's all that was left there. I think it was helpful to have the numerators before I times them. This numerator says take 8, times it by x plus 6. This numerator says take x plus 1, I put it in parentheses because we're going to times it in a minute, and times it by x plus 3. But he's gone, and he's gone, so we don't worry about those. Okay? Now, some of you might be thinking, all right, is this a regular solve or a quadratic solve? Well, you're definitely going to have two x's timesing together here, so you probably have a quadratic to solve here. Let's multiply this out. 8 times x, that's 8x. 8 times 6, oh crap, that's 48. Right here, x times x is x squared. X times 3 is 3x. 1 times x is 1x. And 1 times 3 is 3. Let's put all of our like terms together. That's why I put this line here. I know I'm going kind of fast, but you guys can pause me and slow me down. Again, I'm trying to cut time off of my video, not really working. No like terms combine over here. I have 8x plus 48. This, however, this gives me x squared plus 4x plus 3. Look at it. What do you see? What is the big problem that I have in this particular equation? I have an x squared. That means it's a quadratic, and that means it's probably going to have to factor like a quadratic. So here we go. This is a quadratic. This is where x squared is positive. I need it to stay here. We have to make this side a 0. So I'm going to move the 8x. And I'm going to move the 48. Both of them with subtraction. That will give me a 0 here, which I wanted. It'll give me an x squared, which I already had. It'll give me a negative 4x. And it will give me a positive 3, a negative 48, a negative 45. Okay? This is equal to 0, and it's a quadratic. I really pray to everything that it factors. If it doesn't factor, my work just got, 2, 3, 4 times harder. I don't care. I really would prefer not to do that. I have got to find two numbers that will times to negative 45 and will add or subtract to negative 4. And I'm going to kind of use the shortcut on this because I'm lazy and I'm tired of doing it. A couple ways to make 45. What is that? 15 and 3. 15 and 3, if I times them together, yes, that will work, but they will never add or subtract to a 4. 5 and... 5 and 9? 5 and 9. 5 and 9 have a difference of 4. Those are probably my numbers. Let's see if we can make these work with 5 and 9. I know one of them has to be negative. I know they need to subtract, in this case, to a negative 4. If my 9 was negative, that would make that happen. Okay? Now remember, these are my factors right here. And I can use them, as in I'm allowed to, use them and go straight to my possible answers. But since there are factors here to make them answers, I can either apply ZPP, where I write the factors out, set them equal to 0 and solve, or I can just change the sign. If I get a factor of positive 5, the answer is negative 5. It's the exact opposite. If I get a factor that's negative 9, the answer would be positive 9. It's the exact opposite. Okay? Now, these are the answers we got. We just have to go back up to the top of this board and see, all right, did we get answers we can't use? The only answers we cannot use are negative 3 and negative 6. None of these are a negative 3 and a negative 6. So we, in fact, get to use both of them. Our answer, for example, number 3, is negative 5 and positive 9. No excluded values showed up in this case. Now, what you might be thinking is, Mr. Wally, but what if does that happen a lot where you get 2 answers? Yes, it does. Mr. Wally, does it happen a lot where you only get 1? Yeah, it does. Mr. Wally, can I get 0? Yeah, you can. You can get 0 as an answer. You can also get no, not 0, but no solutions that work at all. And that might just be because something happens here. It might be because the only answers that work are the values we cannot use. So be prepared for that, you guys. Really work on this timesing by the common denominator piece. I know that's going to feel weird to you, but you have to do it. It's in my opinion, the fastest way to get done with these particular types of problems. So those were my 3 examples. You do have you will have a quiz. I don't remember how many questions this is, so I can't mention it here, otherwise I would. Remember, please write down your work. If you are trying to get an A, B, C, D grade and not just a credit, no credit, I need you to take a picture of your handwritten work and turn it in when you do your quizzes. You can either, I prefer that you just share it with me on the Google Classroom site. There's only like 3 of you that are going for a normal grade that I've heard of so far. But do not, absolutely do not wait until the end of the year and say, Whatley, I'm deciding that I want to go to grade. Unless you can have all this work saved and show me it, I will not change it. It will be a credit, no credit. So other than that, I look forward to seeing all of your beautiful faces on Tuesday, those of you that show up. Please make sure that you're doing the work by hand. You can use Photomath to check, but if you're just using Photomath, when you go to pre-cal, Mr. Peoples or Mr. Pear will kick you out immediately when they realize that you cannot do this stuff. So if you can't do it, don't cheat at it. Come see me in a Zoom, send me a remind that says, hey, Whatley, I need to ask you how to do this. I will help you. Do not just Photomath it and leave it at that. Okay, that's all I got for you guys. About a 30-minute video on this one. Could have been better. I will see you all soon.